In a random sample of 2,252 Americans aged 16 and older, 11% of the 1,059 men and 16% of the 1,193 women said they have accessed library services via a mobile device. The values that we are given here are sample values. So this is telling us that our sample value for the first group is 0.11. Our sample value for the second group, these should have hats, is 0.16. And then this is our sample size N1, this is our sample size N2. We're asked what must be assumed in order to construct a confidence interval for the difference in proportions. So if you go back to the previous page, that is where we have our conditions. We have that the two samples must be randomly selected. They must be independent of each other. In addition to that, we need to have our sample sizes be large enough so that these four things are all met. So these are an and. They all four have to hold. These are able to be checked in this example we're looking at, and they do hold. So we're not really assuming that, but we can check that those are true and that those are all at least 10. But what we do need to assume is this part about the independence. So we need to assume that we have random samples that are independent of one another. And all that would mean in the context of this example is that the men and women accessing the library services via the mobile device don't affect each other, like the rate at which they do that. So here we are assuming that the two groups are independent of each other. We are already told in the problem statement that this was a random sample, and we can check that the samples are large enough and that those rules on the previous page follow. So now that everything checks out, we want to look at finding and interpreting a 90% confidence interval for the difference in the proportion accessing library via mobile devices for men and women. So we take our two sample values and subtract to start with, then add or subtract our margin of error, which consists of a z. 90% normal value was 1.645 that we saw back in section 6.1. Then we have the square root of, we take our first sample proportion and then 1 minus that value divided by its sample size, which is the 1,059, plus our other sample proportion, 0.16, 1 minus that, over that sample size, which is 1,193. What we will get here for this difference up front is negative 0.05, and then plus or minus our margin of error of 0.0236. So the resulting confidence interval is negative 0.0736 to negative 0.0264. So this is a 90% confidence interval for the difference in the two population values. And if you look at the filled in notes, you can see the interpretation, which would be that we're 90% sure that the difference in these population proportion of men and women who access the library on a mobile device is between the negative 0.0736 and the negative 0.0264. And then lastly, we're asked if this interval suggests that there is a difference in these proportions, and if so, which population is higher in terms of their proportion. So if we look at this interval for P1 minus P2, what we want to look at is it negative all over? Is it positive, or is it a mixture of positive and negative? So if we look at this, we've got a negative and a negative. So what we're seeing is that we have a negative confidence interval, and what we're capturing in that confidence interval is P1 minus P2. So P1 minus P2 being negative is equivalent to saying that that difference is something less than 0. And what that would mean then, if we just do some math and add P2 to each side, is that P1 is less than P2. So in order to be subtracting and get this negative result all over, the first proportion would have to be smaller than the second proportion. So what we're seeing is that the population proportion is higher for group 2, and that was the women. The other two cases I jotted over here on the side, if we had a positive result, that would mean that P1 is greater than P2. This one was P1 would be less than P2. And for this one, we have no difference. If we have a mixture of positive or negative, then the difference could go either way. And so that would say that there is no difference.